Okay, so today we are going to discuss all elements in two binary search trees. So what you have to do in this particular problem, there are two different root nodes given, so two different binary search trees, and you have to merge the values. For example, this is the one tree, this is again the second tree, and you have to merge them. So what you will do, you will find the lowest element in this particular tree is 1, lowest in this 0, compare it and add it, right? So in this way, if you will merge it, and you have to return that merged list in sorted order, so this will be the answer, right? So how you will return it? One thing you can do, that's very simple, a naive approach. You can add all the elements, iterate through both the trees, add all the elements in the list and sort it, right? So just iterate through this and add to the list and sort it. So you will return the sorted list which is needed. That's one of the approach, but it will take an log n time because you're sorting it. The second approach you can do is use the DFS and also some extra space. So what I will do the in order traversal. So what is in order traversal? Left, root, then right. Okay, so that is the in order traversal. There are some other traversal, pre-order and post-order too. But I will do the in order traversal because if you do the in order traversal in binary search tree, you will get a sorted list. So if you will do the in order traversal in this particular binary search tree, you will get 1, 2, then 4, right? And you do the in order traversal in this, then you will get 0, 1, 3. So these two lists you are created separate, right? From these two trees. Now your task is to merge them. So what you will do, you will create two pointers, for example, I here and j here, and compare ij. So if in this particular case j is smaller, so you will add to the answer list. You are creating now answer list. What you will return, and j you added, so you have to remove this thing from here. Now this j will come here, right? And you will again compare, both are equal. So whatever you want, you can add. I'm adding this one. So this is added here. Now our I will move forward, right? So I will come here, and now again I will compare. This is smaller. I will add it and remove it from here. Then j will come here, again do the same thing, comparison and move. So this is the output which I will receive in this, right? So this, the complexity for this is order of n to for the in order traversal for this tree, same for this. If size is m and n, then order of m for traversing in this, order of n for this, and after so the total size of this list will be m, total size of this list will be n, and we are using different pointers. So the total complexity will be order of m plus n for creating a list, and for doing the in order traversal also order of m plus n. So total complexity will remain same, order of m plus n, right? This is a time complexity. And I'm also using the space m plus n for storing the list and also returning the answer list. So space complexity will also be order of m plus n, right? So this is the second approach. Now you can use the third approach, which is iterative, but you have to do the in order traversal only. Okay, so what you will do, you will create two stacks, right? And answer list, which you will return. So what you are doing in order traversal, you will insert this root node 2 here, 1 here. This is stack 1, this is stack 2. And now I will, because there is left child, I will insert the left child also. And there is also left child, insert it. Now there is no child, right? Not, especially not left child. So you will stop here and compare the stacks top. In this case, 0 is smaller. So I will insert 0 in the answer and come back. So this node is done. You are here right now. So you will go to the right of this node. This node is done from here also stacks. So you will go to the right of the node 3 and insert it and check till left is there. No left is there. Fine. Compare again. So before, this is the mistakes which I did here, that before going to the right, okay, you have to compare this node 1. So what you will do, so this is a common mistake which I did, right? In order traversal is left root right, not left right root. Okay. So what you have to do before going to the right side, you have to compare these two, because this is the root. Next node after left is root. In order traversal, left root, the left root, then right. Cool. So this is the root. So left you are done with. Now you have to compare root with this top. So these two will be compared. For example, I'm taking this one out. So I will clear it from here and add it here, right? One. Now this is done. This is the root. So I have to compare again. Now this is smaller. I will add it. This is done. This will be gone. And after that, I have to add the 3 in this stack, which is the right of this. So left root are done, right? We have to go. And we will go till the point left is there for in order traversal, right? So there's no left. This is done. So I will compare 2, 3. 2 is smaller. This is also done. I will insert 4 in place of 2. 2 is popped, right? Now 4 is there. And now again compare. 3 is smaller. 3 will be added. Done, right? This 3 is done. And there's no remaining element. All the elements are done from here. I will add 4. And this is completed. So what I am doing here, I am getting the answer list, right? But the thing which I am doing here, I'm not using any extra space. I'm using the extra space for answer list, but not using for storing the list 1 and list 2. So I will explain one important factor here. In that thing, I was using the recursion, right? So recursion uses the functional stack. So which is similar to using some manual stack which we create and then use it in the iteration. And this space will remain same. But this was a little extra space. So it will not, overall it will not affect, because still the space complexity will remain same, order of m plus n. But little bit optimized, I will say, space wise, because this is the only space which we are saving. But this is little complicated than the previous approach. So I will suggest to use the previous approach. This is about this particular question. And if you have any particular doubt, definitely ask in the comment section. I will definitely answer. Okay, thank you.